Okay, good morning everyone. Today I'm gonna talk about the last topic of chapter 2. And previously, you remember we have five equations. I believe we now memorize all these five equations here, right? And the main idea over here is every time you have five variables, and then your final goal is finding all these five variables. And the key principle here is you must be given three variables, right? And then you are looking for, so assuming, you know, these three are given, and then your goal is finding these two, right? Right? That's the main idea of our last lecture. And then this section, the free fall motion, is nothing but one of that equation, but this is about the vertical motion. So free fall motion is if an object moves under the influence of gravity only and no other forces rather than gravity, we call the resulting motion free fall motion. So all objects in free fall, regardless of their mass, have the same acceleration, which is a g, you know that, which is a 9.8 meter per second square. We call it gravity, right? On the Earth, air resistance is a factor, but in general, we'll restrict our attention to situation in which air resistance can be ignored. So you can always assume, until I mention, you know, you can ignore air resistance. Okay. And yeah, this is sometimes you travel, right? In the moon, you will see the gravity is smaller, and then we'll talk about later how to calculate gravity of the earth and the gravity of the moon later. And free-fall motion again is nothing but the acceleration. It's just another one example of acceleration. So for example, if you see a, your velocity is increasing, right? So the velocity change is acceleration. So your acceleration direction is a downwards. So that means the acceleration sign is a negative, right? So if you draw V t graph whose slope is acceleration, right? So then you have a slope minus a 9.8. And be careful, this is also true even when the object is moving upward. And then this is the, one of the section we had, you know, previously about the direction of the acceleration. So I said there last time, direction of acceleration is the same as a direction of the force, right? So now, for case A, object is moving downwards, and then in order to, speeding up, which direction of force you need, right? So you have to, press it down. So the direction of the acceleration is a down. Even when the object is moving upward, but slowing down, which direction of force you need in order to slow down an object moving upward? You need a force downward as well. So both cases, you have acceleration negative 9.8 meter per second square. This concept is very important. Now test, you will see a lot of questions related to this part, right, in the next, your first exam. And free fall acceleration, again, this is a gravity, points always down. So no matter what the direction object is moving, that's exactly what we just talked about, right? Any object moving under the influence of gravity only, and the other force, and there's no other force, is a free fall. So free fall means gravity only, without any other force. The value of a free fall varies slightly at different places of the Earth, but you can say the magnitude of the acceleration g is 9.8, but you can always use a minus 10 meter per second square. Okay, we don't need a 9.8. Okay, and the definition of a gravitational acceleration is g, right? And then we always have a negative sign, meaning that the force or acceleration direction is a downwards, right? And So we have a question here. A ball is tossed straight up in the air at its very highest point. The ball's instantaneous acceleration is up, again, negative, right? Why? Again, as I said here, the free fall acceleration always points down, no matter what direction of an object is moving. So even when the object is at the top, gravity is still negative, right? G, gravity is always pulling the object downwards. No matter, when it was, object is moving up, when the object is at the top, when the object is moving down, doesn't matter. Gravity here, here are the same. So an arrow is launched vertically, right? And then it moves straight up, maximum height to C, right? And then falls to the ground. The trajectory of the arrow is shown here. At which point of the trajectory is the arrow's acceleration the greatest, least? You can ignore again and register. The answer is what? It's the same as this question. It's always the same, right? Which is a minus 9.8 or minus 10 meter per second squared. Again, the same question, we have the same physical situation where acceleration is always a minus 10 meter per second squared, right? So then if you draw the VT graph, right? So what would be the answer of this question? You pause the video and think about it. But the answer is of course, D. Why? Because if for A, B, C, E, if they are answer, then what happened? Your slope here is negative. Slope here is positive. Slope here is negative, but at some point the slope is 0, at some point another value. But your acceleration here, from here to here, you never change the acceleration value. So you should have a one straight line whose slope is a single value, right? So the answer is D. So the conceptually, this question, the same questions. And then the same thing. So it moves straight up to the maximum height, then falls to the ground, the same situation, right? Sorry about that, that's a solution. And then a heavy rock is dropped from the rest of the top of the cliff and falls 100 meter from hitting the ground. How long does the rock take to fall the ground, and what is the velocity when it's hit? So now this question is exactly same as the previous section, except what? Your motion is now horizontal, the vertical motion, right? So the only difference is the last time, what were 5 variables? So you have a displacement, and then you have a initial velocity, and you have a final velocity, and you have an acceleration, and you have a time, right? So this is 5 parameters you always play with, and then the principle is what? 3 of these values must be given, and the question is finding the other 2, right? But now everything same, but now because this is one-dimensional motion but vertical motion, so the only differences we have here is the delta y instead of delta x, and then v initial velocity, v final velocity, and acceleration and the time same for the free fall motion, right? But if I go more details with this case, I'm gonna specify. So in other words, this is what? X. This is a X. This is a X. Sorry. This is a horizontal acceleration. This is a horizontal initial velocity. This is a horizontal final velocity. But time is the same, of course. So in other words, this is a VI, Y. This is a V final, Y. This is a V, A, Y. So the principle is the same. You will be given 3 of these 5 values, and then finding the other 2 is your homework, right? But very important thing for in the free fall motion, you already are given one variable, which is this one. So even though they didn't say anything about the acceleration, as long as it's a free form motion, you can always assume your first given variable is a vertical acceleration, which is minus 910 meter per second square. So this is your first given variables, and then your next task is what? To find two more given variables out of these four, and then finding the other two, right? So now let's see the question carefully. The heavy rock is dropped from the rest, right? So then what does that mean? So this means it's a free form motion, right? So your first variable a, y actually is minus 10 meter per second square. And it says it's dropped from rest. So that means your initial velocity vertical is a 0 meter per second. This is your second information. And at the top of the cliff and the force 100 meter. So your delta x is a 100 meter. So then now you have all three given variables, right? So the question, I haven't read the rest part of this question, but the question must be either finding what is your v final velocity vertical, and then how long will it take? The question must be one of these two. And one very important and the most common mistake I see every time, every semester is here. It says for 100 meters. So basically, this is your y-axis. This is your initial position, and then your final position, right? So let's assume this is 100, and this is a 0, the ground, right? So your delta y for this case is what? Y final minus y initial, right? Which is a 0 minus 100. So your delta y, sorry, this should be delta y, must be minus 100. Be careful about it. So then now you have a 1, 2, 3 variables, and then depends on which, what they are asked. But you see how long, right? And then they also ask what is the velocity when it hits. So it's a final velocity. So it doesn't matter whichever you find first. Okay, good. So then now the rule is straightforward, right? Again, we're gonna use the equation number. Let's see, let's go. This equations, right? Displacement is a VIT plus BI or B0, 1/2 times of AT squared, right? So now we have a equation y, delta y is a BIT plus 1/2 times of AT squared, right? This is to find the t, but I don't think this time finding t first is not a smart choice. Why? Because you see, you have to solve quadratic equation to find here, right? So again, let me, check our variables, right? Delta ay is minus 10, delta y is minus 100, and the vi is a 0, right? So I think that we can use this one this time because our VI is 0. So sometimes when your VI is non-zero, you better not to use this formula because then you have to solve your quadratic equation, right? So then delta y is minus 100 and the VI is 0. So this is 0 plus 1/2 times a is 10. You can always use 10 instead of a 9.8 and t squared. So this is a 5. So if you divide by, no, this is minus 10. So you have a minus 5. So then t squared is a 20. So your t is a root 2, 20. So you have a 4.5 seconds. And then you can use any other equation to find your final velocity. For example, your final velocity that you're looking for is your initial velocity plus at, right? So then your initial velocity again 0, a is a minus 10, we see t is a 4.5 seconds, so this is a minus 44, 45 or meter per second. That's what you got here, right? So you see, this is exactly same as a earlier section. The only difference is this, whenever you see again free form motion, you can have a first given variables, which is ay minus a 10 meter per second square, right? Thank you. Today's lecture is relatively short, but again, this is a very good review of your previous section, and make sure again you will see this type of question over and over to the end of this semester and next semester physics 2 as well. Okay, thank you. I will now also assign homework 2 as well. And then I know everybody has a problem with the homework 1, because of the library didn't have a proper textbook, so I give you a lot of extensions for your homework 1, but you have to submit your homework 2 on time, please. Thank you.